This is 7.8 compound and simple interest. When making an investment, you are paid interest on what you deposit or put into the account. The interest you earn on the loan depends on the terms of the loan. Interest can be added once a year or at different times through the year. Simple interest occurs when the amount earned at the end of each year is a percent of the original deposit. So that makes A is your amount of money, your total amount. P is your principal. Which also means the initial amount. R is the rate, which we write as a decimal. So percent as a decimal. And then T is your time, typically in years. So you're going to have two different ways to represent this equation, and that's through appreciation, which is growth. So if you're earning interest on a bank account, or depreciation, which is decay, whereas you're losing a percent of money. So compound interest occurs when interest is added to the principal each period for the interest before the next period is calculated on the new principal. So when things are happening multiple times a year. So A is still the total amount. P is still your principal, which is your initial amount. R is still your rate, which is a percent written as a decimal. And then T is still your time. The only difference is now we have this variable N. So N is conditional. It can happen annually, biannually, monthly, quarterly, daily, or weekly. So when it's annually, N is 1 because it happens once a year. When it's biannually or semi-annually, N equals 2. Monthly, N equals 12 because there's 12 months. Quarterly, N equals 4 because there's 4 quarters in a year. Daily, N equals 365. And weekly, N equals 52. So now we're going to compare what actually happens between simple and compound interest. So we have Edward. Edward deposits $500 in the account. So that is your initial amount, your principal. And it earns a 2% interest. So earns means we're going to be adding 2% interest. So now we have everything we need in order to write these. So the amount of money earned, the amount of money he has is the principal, 500, multiplied by 1 plus our 2%. And remember, 2% is 0.02. So 2 cent, 2% as a decimal. Both of those are written the same way. So we start off with the 1 from our formula. We're adding because it earns, and there's your 0.02, your 2%. And it says that T equals 5. So your amount of time is 5. So when you plug this into a calculator, you end up with the amount of money is equal to $552.04. So then if we do the same thing, simple interest with t equals 10. So your amount of money is equal to your initial deposit, your principal, the 1 comes from the formula, the 2 is your percent, the 0.02 is your percent, and this time we're talking about after 10 years. So when you plug that into the calculator, you get $609.50. So then the next one, we're still doing the same thing. We're finding out the amount of money based on a principal of 500 multiplied by 1 plus 0.02. And this time our t value is 15. So when you multiply that out in the calculator, you end up with A equals $672.93. Now remember, because this is money, whenever our word problems deal with money, you always want just 2 places after the decimal. So then if we look at the compound interest, this is where things change a little bit. So we have still the same formula almost. So we have A equals, the principal is 500. We have 1 plus because we're still earning. But this is where things change. So we have this word quarterly. That means 4 times a year. So we're going to add that 2% 4 times a year. And then 4 times t in your exponent. And t is 5. So again, this is going back to that compound interest formula up at the top. So we have this right here. So our n value is that quarterly. So everywhere we see an n, we have to put a 4. T is 5, so in the exponent you have 4 times 5. So when you plug this into the calculator, you end up with the amount of money you currently have is $552.45. So then if we looked at it compounded monthly, so that means your n value is going to be 12. And you have your t value given here. So we have the amount of money is based on your principal multiplied by 1. Again, we're earning, so it's addition. The n value is 12. So in the exponent, we have n times t. So when you plug that straight into your calculator, just as you see it, you end up with the amount of money at this point would be $610.60. So the last one, we have an n value. This biannually means 2 times a year. So n is 2. We have the t value of 15. So when we plug it in, we say our amount of money is equal to the $500 you initially put in times 1 plus 0.02 over n is 2. And then the exponent is n times t, so 2 times 15. So when you plug this straight into the calculator, you end up with $673.92. So in comparing all of this, we have for simple interest after 5 years, it gives us $552.04. On compound interest after 5 years, but compounded quarterly, we end up with $552.45. So every single time, all of those compound interest amounts are higher. which lets you know that a compound interest when you're earning money is the way you want to go. So on the back of the paper, it says an exponential function will always outgrow a linear function given enough time. So now we're looking at $8,000 in an account. So that's our principal. And it earns, so we're adding 2% annual interest. So if it's happening annually, your end value is 1. So we have annually, then we have quarterly, then we have monthly. So we're going to write our formula to cover all of this. And we want to know at the end of 4 years. So your formula, the amount of money you have, we're going to write it generic and then plug in the values. So the amount of money you have is your $8,000. We're earning, so we're adding. 2.5 written as a decimal is 0.025. So we have 1 plus 0.025 over n with the exponent n times t. So when we plug in all of these values, and we know our time is 4 years for all of them, so I'm actually going to change that to n times 4. So the only thing that's changing as we look through this formula is that we want to check it out based on it being compounded annually, quarterly, and monthly. So when we plug this in for annually, that means your n value is 1. So when we rewrite, we have A equals 8,000 times 1 plus 0.025 over 1 n is 1, your time is 4. I'm going to change my colors on those n's. So 1 and 1. So when you plug this into the calculator, annually, you would end up with $8,830.50. So then if you looked at this quarterly, which means that your n value is 4, we would write A equals 8,000 times 1 plus 0.025 over 4 to the n times t. When you plug that straight into your calculator, you end up with 8,838.62. Lastly, we have monthly. There are 12 months in a year. So monthly means your n value is 12. So when we write our formula, we have A equals 8,000 times 1 plus 0.025 over 12 n times t in your exponent. And when you do that, you end up with $8,840.45. So based on this, the way that you would prefer to be building interest is monthly. So now we're going to talk about some real world application. So we have a couch. A couch is $800. That means the principal amount on that couch, that initial amount, is $800. And it has a sales tax of 8%. Sales tax is something extra you have to pay. So when we write this, the amount for that couch is that $800, and we multiply. So we're adding on 8%, 0.08. Remember, 8 cent is written the same as 8%. So we have 1 plus our 8 cent. Now, the reason I didn't put this over in is because it only happens once. So our exponent is also going to be once because you only pay sales tax one time. So the amount for that couch is $864 once you include that tax. So did the price grow or decay? It grew. So then we have a hoodie. Says a $30 hoodie. So $30 hoodie is our principal amount, and it's on sale for 20% off. Now, because it's on sale, we know the price is going to decrease. So we're going to subtract 20%. Written as a decimal is the same as 20 cents, which is 0.02. So when we're looking for our amount of money, we take our principal of $30. We multiply it by 1 minus, because we're depreciating, we're decaying, 0.20. And that 20% off only comes off one time. So we have an exponent 1, and that hoodie is going to be $24. Now, another way that you could have written each of these formulas is based on what's inside the parentheses. So because it only happens once, we have two different numbers inside the parentheses. We can actually rewrite this as A equals 800 times 1.08. So on the hoodie, we have 1 minus 0.20. So we could have also written A equals 30 times 0.80. You can always combine what's inside the parentheses because they're grouped. So then we have a chair. It's a $600 chair with 8% sales tax. So because this one is just like the couch, I'm going to let you guys do it. And you can check your answer on that one later. The next one, you're shopping at Kohl's and find some pants for $50. So there's our principal. The pants cost $50. Now, they're 20% off, but then you have a coupon for an additional 20% off. So how much are the pants? So we have the amount for the pants is equal to your principal of $50, 20% off. Remember, because we're taking off the 20%, we're subtracting it. So we take our full amount of the price. That's what that 1 represents, is 100% of the cost. And we're taking away 20% of the cost. But we're also going to do that twice. So when you plug that into a calculator, you find out that the amount of that $50 pair of pants with a 20% off coupon twice is $32. The next one is just like that one, so we're going to go ahead and skip it. So then this next one is trying to match the correct answer. I want you guys also doing this one on your own, but we'll do the next two together. So we have a car that's $25,000. So there's your principal. We want to find out what it's worth after 7 years if it depreciates 9% annually. So we want the amount of the car that originally cost $25,000. So the whole price of that car, the whole price is depreciating. It's going down 9%. 9 cent written as a decimal is 0.09, so 9% is also written that way. And because we want to find out after 7 years, our time in the exponent is 7. So the value of that $25,000 car after 7 years with a 9% depreciation rate is $12,919.03. So again, another way you could have written that equation that represents the same thing is you could have had 25,000 1 minus 0.9 is 0.91. 1 minus 0.09, and then 7 in the exponent. So you know it's depreciation because the number inside the parentheses is less than 1. When you multiply something by a number less than 1, it gets smaller. So our next one, what is a house worth if we bought it at $120,000? So there's your principal. It has gained, so we're adding 1.2% annually for the last 3 years. So when we set this one up, we have our amount of money is based on that 120,000. And that whole amount is going to be gaining at a rate of 1.2%, so 0.012. And we want to find out after 3 years. So again, the same thing we did before is I want to write it in a different way. So we have 120,000. 1 plus 0.012 is 1.012, and our t value is 3. So again, that number in parentheses, that base, is larger than 1, which lets us know that this is increasing. So that $120,000 house that's increasing by a rate of 1.2% after 3 years would be worth $124,372.05.